This video is about graphing linear equations. So in the last video, we talked about how to determine if a graph was linear or if a relationship in a table was going to be linear. Today, we're going to look at how to graph those relationships from an equation, I should say. All right, so Anthony's family wants to go to a concert. The cost per person for admission is $12, plus there's a one-time parking fee of $10. Determine if the relationship between the cost and the number of people is linear. And then it says to transfer the coordinates from the table to the graph below. All right, so this is similar to what we've done before. The cost of one person, so admission means to get in, right? Then we'd have to multiply that, or for one person that's $12, but they have to pay this one-time parking fee. So 12 plus $10 is $22. All right, if two people go, then I have to multiply 2 times 12, because it's $12 per person. So 2 times 12 is 24, but I still have to pay for parking. So then that would be 34. 3 people go, then it's going to be 3 times 12, which is 36, plus the parking, which would be 46. And then 4 people go, 4 times 12 is 48. Add the parking, it's going to be 58. So not everybody's paying for parking. They can all ride together, so they only have to pay it once. All right, so if I go ahead and graph these, this is X, this is Y, so I'm going to go over to 1 and up to 22. So you just kind of have to guess. 2 and 34, 2 and 34 is not quite halfway. 3 and 46 is about, it's a little more than halfway. And 4 and 58, almost to 60. Okay, so if I just connect the points here, it looks like it is forming a line, a straight line. So is the relationship linear? Yes, it's linear. Oops. And then why or why not? It's a straight line, okay? A graph is a straight line. Okay, but it also has a, let's say, and has a constant rate of change. And really, the rate of change is a better way of determining that, because sometimes our graphs are not perfect. So we could go back and look. The difference between 1 and 2 is 1, 2 and 3 is 1. The difference over here, if I do 34 minus 22, you get 12. If I do here, 46 minus 34, I get 12. Yeah, so I can see that there was a constant rate of change, so my graph is good. Okay, so the question is, where is the graph when x equals 0? And I went ahead and put it there, but why did I put it at 10 and not at 0? Okay, so if I continue this line, where does that 10 come from? Well, you see how if you want it to go to the concert but not go inside, would you still have to pay parking? Yeah. I mean, unless you're just hanging out, I guess, outside the gate or something like that. But yeah, so even if 0 people goes, there's still going to be this parking charge. And so that's why at 0, the graph is at 10. And why is that there? It's because of the $10 parking fee. So there was this extra amount. We were paying for each ticket, but then there was this also extra charge, and that's where that 10 came from. All right, so the question now is, does the equation y equals 12x plus 10 represent the situation? Well, let's think about it. Okay, so y equals, that just means is the cost equal to 12 times x. Well, what was x? 12 was the number of people. So is that what we did? Did we multiply times 12 and then add 10? So yeah, we did 1 times 12 and then we added 10. Here we did 2 times 12 and then we added 10. 3 times 12. So yes, this equation represents the situation. Okay, and then they ask, why is x being multiplied by 12? All right, so why are we having to do this part right here, 12x? Remember, a number next to a letter means multiplication. That's why I know it's multiplication. Okay, so we're multiplying x times 12 because x is the number of people and 12 is the cost. So to find the total cost per person, you have to multiply, right? All right, so why is x to find the cost? Let's see, if x is the number of people, I'm going to abbreviate number of people, you must multiply to get the cost of the tickets. All right, so x is being multiplied because we need to find the cost. To find the cost, x is the number of people. We multiply that to find the total cost of the tickets, not just one ticket. All right, so it says an equation like y equals 12x plus 10 is called a linear equation. Can you guess why? Because it's an equation whose graph is a what? It's a straight line. And then to graph a linear equation, what did we do? We made a table, and then we use that table as our ordered pairs to graph the line. All right, so that's basically what you're going to be doing. You're going to be given an equation like this one, and then you're going to graph it on a coordinate plane. All right, so let's do it. There are 4 steps basically to do this. First thing you do is you want to make a table. You want to choose at least, let's see, you need to choose at least 3 values of y, and here they're giving us 4, but really you need at least 3 because that'll tell you if your points are lined up. And then you're going to substitute in values of x to find y, and then you're going to graph the ordered pairs, okay? And it's always x first and then y. All right, so here's 1. This is the equation, y equals x minus 1. All right, we want to graph this equation on here. We want to put this on here. They're telling us it's a linear, so it should graph as a straight line. All right, so the first thing you do says make a table. Well, this is nice. They've already made it for us. Okay, it says choose at least 3 values of x, so go easy on yourself. You don't have to choose any fractions. You don't have to choose big numbers. You want to pick numbers that'll fit on your graph. So 0, 1, and 2 are great. You can use negative numbers too if you want to. And then since we've got 4 spaces, I guess we'll use all 3, or 4, all 4. All right, so then it says after we choose our values of x, we're going to substitute in values for x into the equation, right? And then we can figure out what y is. So if y is this part, x minus 1, then I need to do this in order to find y. So the first one would be to say replace x with 0. What is 0 minus 1? Well, remember I can write subtraction as addition. I change opposite. So keep that, change to add, change to the opposite, which would be negative 1. So 0 plus negative 1 is negative 1. And then if I write this as an ordered pair, 0, negative 1, that's the one I'm going to graph. So I could go over to 0. I'm really not going over. I'm starting from 0, and I'm going down to negative 1, which is not on the graph, but if this is negative 2, then this has to be negative 1. Right? So then if I try 1, I'm putting this into this problem right here. So I'm replacing x with 1. So this would be 1 minus 1. What is 1 minus 1? 0. All right? So then if I write this as an ordered pair, I get 1, 0. Right? If I replace x with 2, because that's the equation, 2 minus 1. What is 2 minus 1? 1. My x is 2, my y is 1. Oh, I forgot to graph it. So 1, 0, I'm going to go over to 1 and then stop because I'm not going up or down if it's 0. For 2, 1, I go over to 2 and up to 1. For 3, x is going to be 3 now, so what is 3 minus 1? 2. So my point is 3, 2. So I'm going to go over to 3 and up to 2. All right, and then is your graph forming a line? Well, it should be because all of these are going to be linear equations, but you can connect them to show that it's a line. All right, let's look at the next example. Graph y equals negative 3x. So we talked about this a little bit in the at the beginning. When you have a number next to a letter, that means multiplication. So we're going to be multiplying negative 3 times x. All right, so we need values of x. Let's just do a negative 1 just for fun. So let's try negative 1, 0, 1, and 2. You don't have to pick these points. They're all small, so that means they'll probably more likely to fit on my graph. All right, so I'm going to replace x here with negative 1, and then multiply it. So negative 3 times negative 1. What is negative 3 times negative 1? If you've forgotten your integer rules, when you're multiplying, you can use that sleeping man guy. So a negative times a negative is positive 3. All right, so my point is negative 1, positive 3. I'm going to go over to -1. Again, that's where -1 is, even though it's not labeled. And then up to 3. I'm going up because it's positive. All right, if I plug in 0, so now I'm replacing 0, or x with 0, so -3 times 0, which is 0. So my point is 0, 0. That's just right in the middle, in the origin. All right, -3x would be -3 times 1 this time. So a negative times a positive is -3. So this would be 1, -3. Remember that guy? All right, so I'm going to go to -1. No, I'm sorry, +1. And then down this time because it's -1, 2, 3. And then 2, I have -3, replace x with 2 times 2. So negative times a positive. Negative times positive is negative. -3 times 2 is -6. My point is 2, -6. All right. And then I'm going to go over to 2, and this time down to 6, which would be down here, 2, -6. All right, so is this forming a line? Yes. But this one's a little interesting. What makes this line different from the other line? Okay, they're both lines, they're both straight, so they're both linear. This line is going down. See how this line's going up? All right, we're going to talk more about that in other stops, but just sort of be thinking about it. All right, an outdoor adventure company charges $9 per hour for a mountain bike plus a $5 fee for a helmet. The equation C equals 9h plus 5 describes the total cost, C, for h hours to rent a bike. Represent this linear equation with the graph. All right, so the only difference this time is instead of using x and y, they're using c and h, but it's the same thing. All right, so we're using h as what we have to plug in, right? So the number of hours, and then c is going to be the cost, how much it costs. All right, so again, we're going to just use easy numbers. You can even use 0 here if you want to. So 0, if I use 0 here, 0, 1, 2, and 3, right? Then 9h means 9 times h, and then I add the 5. So 9 times 0 plus 5. What's 9 times 0? 0 plus 5 is 5. Okay, so why is it costing you $5 if you're not even riding? Because you still have to pay for the helmet, all right? So would anyone do that? Probably not, but maybe if you're just a rider, maybe if you're not going to actually, I don't know. That doesn't make any sense. All right, but it's because of that $5 fee. All right, so my point is 0, 5. All right, 9 times 1 would be the next one, plus 5. So 9 times 1 is 9. 9 plus 5 is 14. So this is the point 1, 14. For t, I would do 9 times 2 plus 5. 9 times 2 is 18. If I can't do that in my head, I'm adding it up. This is 23. This would be 2 and 23. And then 3, you would have 9 times 3 plus 5. So 9 times 3 is 27. Add 5, and you get 32. All right, so my point is 332. And just so you know, right, I'm using the 0 and the 5 to get 0, 5, the 1 and the 14, right? H first, then C. So in my graph, the H is normally the X, so this is really the hours down here, and this is now the Y, which I am calling C for this problem. So hours here and cost here. So when you don't even ride the bike, you're still going to pay for the helmet. So 0, 5 would be right here in the middle. 1, 14. So I'm going to go over to 1 and up to 14, which is not quite halfway. 2, 23, go over to 2 and 23. It's about right there. 3 and 32, go over to 3, up to 32. Okay, and you can see that this is forming a line right here, and it should, since these should all be linear equations. All right, so what were the steps for graphing? You want to make a table. When you do your homework, tables aren't going to be written for you, so you're going to have to make your own. Then you're going to choose at least 3 values of x, maybe 4 is even better. Substitute in values to the x, all right? The ones you chose, you substitute in for x, and then you use that to solve for y. And then once you're done, you graph your ordered pair. All right, see you soon.